In this problem, we're going to take a very different look at how to approach one of these different types of problems where we're looking for the local extrema. All right, so notice that we're only looking within this interval from -5 to 7, and we're just looking for the local extrema. Now remember that the local extrema happen at the critical points, that is, where the derivative equals 0. So already then, I can actually focus my attention quite significantly just because I'm looking for where the first derivative function equals 0. So already I'm only looking at those 3 columns. Those are my 3 contenders. Now of those, it might be a local maximum, might be a local minimum. How can I tell? Well, remember I can use the second derivative to tell me that. At a local maximum, I should see a graph that's going from increasing to decreasing. That is, the graph is concave down. Well, concave down means that the second derivative is negative. And so if I look at my table here, I can see a negative second derivative here and here. So both of those two represent a local maximum. So then, what is the actual local maximum that I'm going to write there? Well, for this first one, if I look up to the top, I can see that the x-coordinate is -2. And then I need the y-coordinate. The y-coordinate is the f of x value. So in this case, that would be 7. So my local maximum is at -2, 7. But remember, there was another one as well, because here the second derivative was also negative. And so then that point would be at 650. And then our local minimum, that comes from the place where my derivative was 0, but where my second derivative was positive. And so the coordinates of this point are going to be at 1, -2.